Hello and welcome back. In video number 17, we had modeled a goalpost frame using the text editor where we had manually typed in the stat commands. However, this is not convenient always. Text formats can prove to be extremely powerful, but generally if combined with the use of graphical user interface. Graphical user interface alone is sufficient to do the modeling like the text editor is. So in this video, we will model the same goalpost frame using the graphical user interface only. But before we proceed to do that, please take a moment to hit the subscribe button and join us in this wonderful journey of learning structural analysis with STAAD. So let us click on New to open a new STAAD file. Let us name the file as goalpost frame goalpost frame underscore using the GUI, which means the graphical user interface, and you need to select a location and ensure that the type is analytical and the units are in metric. And with this information, let us click on the create button and you will be led into the modeling area of STAAD.Pro. Now let us go to the utilities and command file to get into the text editor, and we need to actually change the stat space to stat plain. We have to change this from within the editor. If by default stat structure type is space, but if you want to change it to plain, you have to get into the text editor and change it. Go to the file option and click on save to save the changes you made. Now let us come out of the editor. Note that in case you do not press the file and save, as soon as you press this button, the cross button to come out of the text editor, you will be prompted to save your changes. So let us come out of the text editor back into the graphical user interface. Now the input units would be mentioned here at the bottom, the right hand bottom side of the screen, and you could see that our input units are kilonewton meter. Now by default, analytical modeling and geometry would be highlighted. In case you have any other option highlighted by chance, press the analytical modeling and geometry to come back to this particular mode. If you are in this option, you will see the node coordinate box on the top and the member incidences box or the member table at the bottom. This is also called the node table, and this is called the member table. So if you are in this analytical modeling geometry option, you will see both this node table at the top and the member table at the bottom. So let us start by typing the nodal coordinates in the node box or the node table. You will see that the units are mentioned as M, which means the units are in meters. Now our first node, which is node number 1, the node number is mentioned here, has the coordinate of 0, 0, 0, and we will type it accordingly. So we type 0, we can hit the tab button, or we can use our mouse to navigate through these various windows, which looks like Excel sheets. And as soon as the coordinates appear as 0, 0, 0, you would be able to see the node that has been created in the modeling area. If you actually go to the select option, select the node cursor, and if you select this node, you will see that being highlighted. I just highlight this just to make it more clear to you. Then we want to create the second node, which is the node number 2, which has coordinates of 0, 3, 0. So we go here, type in 0 for the x coordinate, go to the next window which is the y coordinates for node 2, type in 3, enter 0 for z, and you would see that now we have the node coordinate default by default, so we can see that node 1 and node 2 has been created. I mean, like if you actually go and press shift plus n from the keyboard, you would see the node numbers being displayed. So let us keep the node numbers on so that you would be able to see them on the screen as soon as it is created. Now, going back to the x coordinate for node number 3, what were our coordinates for node number 3? We had the x coordinate as 5, the y coordinate as 3. I'm hitting the tab button from my keyboard to navigate through these windows. You can also use the mouse to navigate through the windows. So you could see that now as I've entered the coordinates of node 3, that node 3 has also been created on the screen. Finally, we want to enter the coordinates of node number 4, which has the coordinates of 500. Now let me use the mouse cursor to actually enter the coordinates. So press the mouse here, enter 5, press the mouse here, enter 0 and 0, which has already been actually entered. And you could see that node number 4 has also been created on the viewing area. Now, to create the beams, the first beam number 1, so node A is nothing but the start node that we had explained in one of our past videos. Node B is the end node of the member. So beam 1 or member number 1 has the start node as node number 1 and the end node as node number 2. And as soon as you press enter, you would see that the beam or the member has been created between node 1 and node 2. Let us, for member number 2, it is created between node 2 and node 3. So for node A, we enter node 2, and for node B, we enter 3. And as soon as we go to any other window, the viewing area or the modeling area would refresh itself, and you'd see that the beam number 2 has been created. Finally, we had one more beam, which is between node number 3 and node number 4. And this creates the member number 3. Now, if you want to view the members, the member numbers, beside the members, you can hit Shift plus B from the keyboard, and it will display the member numbers on the viewing area. Again, by default, we are looking at it as an isometric view. So we can go to the view option, select the front view to view the frame from the front. Well, you may get confused to see me use the word beam and members interchangeably. Well, do not get confused. I understand that a conventional meaning of a beam is a horizontal member which carries its loads primarily by flexure, while the conventional meaning of a column is a vertical member which carries its load primarily through axial loads and bending. Instead, the beam is representative of both the conventional beam and columns and or any other member. So please do not get confused if you see me using the word beam or members interchangeably or loosely. Now we have said that STAAD would process the commands only from the text editor, but in this case we have defined everything that we have in the graphical user interface. Now let us go into the text editor. Let us go to the utilities, command file, and a safe prompt is displayed saying that something has changed in the text editor since we have last seen it. So we click on the Save button and we go into the text editor, and lo and behold, whatever we have defined in the graphical user interface has been written in the text editor. So let us now get out of the text editor. So we see that the graphical user interface is just a wrapper built around the text editor. Every work that we do in the graphical user interface is saved in text commands in the text editor. However, there are situations where typing in the text commands can prove to be more easy than using the graphical user interface. So we'll see such situations in the future as we go deeper. I hope you have liked whatever I have taught today. If you have, please do hit the like button and please press the bell icon for more notifications from the Structural Insider channel. See you in the next video. Till then, bye.